Hello everybody. In this video we will create a small tutorial where we will be using wine quality dataset which I have downloaded from Kaggle. I will post the datasets and uh, the Python notebook, the Jupyter notebook that I'm using here on my GitHub page, so you can take a look at it. So let's import some of the packages. So import pandas as PD. So pandas is going to be our data analysis package, and we will need numpy as well. And from TensorFlow we will be using Keras to build our neural network, the model from Keras. And we will have Sequential as our data visualization package. So once we build our model, we will use Sequential to visualize it. So let's import everything. And once this is done, then we will create a data frame by using pandas read CSV functions. So we will read it. Right now my file is in the same folder as my wine quality datasets Python file is. So you can see my CSV file is here, and the wine quality, the Jupyter notebook, is also in the same folder. So you don't need to do anything. If not, you can always provide the actual path. That's not a big deal. Let's look at the first 5 rows of it. So if you put dataframe.head, it will show you the first 5 rows of your data frame. This is a CSV file. So it has acidity, volatile acidity, and bunch of other things. So by putting head, you are looking at the first 5 rows. If you can put anything you want. If you want to see only first 3, dataframe.head, first 3 rows, you can put dataframe.head 3. Okay, so let's take a deep dive into our data sets and data types. So dataframe.info, that's going to give a complete overview of your data file. So here it tells us that we have 1599 entries, and also we have 11 columns, and they're all indexed. You can, if you want to just the name of the columns, you can do dataframe.columns. That will give you the list of columns in a list format. I want you to focus your attentions this number here, 1599. So this one has 1599 entries, and then look at each of those columns. It has 1599 non-null values. That means nothing, no data is empty. So everything is packed. So we are good to go. And you can see the data types on each one of the column. So you want to make sure that you don't have any null values. So our data set is good. There is another way you can check this, is data frame is null dot sum. This would also give how many null values you have. So you see every column has 0. So this means we don't have any null values, so we are good to go. However, let's look at our data sets here. So our quality is written as 5, 5, and we probably have a bunch of other numbers. So let's see how many values we have. Data frame dot quality. Then we can do something called value counts. That would give us, okay, so it has, you notice here, so it has 681 of those numbers are 5, 638 are 6, 199 are 7, 53 are 4, 18 and 10. So these are numbers. So let's divide this into 2 categories. Maybe anything below 5, we call it bad. Anything above 5, like 6, 7, 8, we're gonna 6, 7 and 8, we're gonna call them good. So that's kind of right in the middle. So that's, we can separate them bad and good. You can separate any way you want. So before we do that, let's create X variable. So we are trying to predict wine quality based on the property up to here. So we can, so these are the categories that may dictate if the wine is good or bad. Okay, and this is gonna be our output, our quality. Okay, so let's create two variables. So x would be data frame dot drop. I'm gonna drop columns, and columns equals to quality. What? Columns equals to quality. So that's after dropping the data quality column, whatever left over is going to be your x, and our y data frame would be data frame and the column quality. Okay, so if you want, you can check the x dot head first two rows. So you see our x datasets has fixed acidity, all the things except our quality column. And you can also see the y dot head first two rows. It has all the qualities are in there. Okay, so we have split our data set into x and y. Next, what we're gonna do is we're gonna split our y's into bad and good. So let's create a bins. So I'm gonna create a bin. It's gonna be a, so our bin will I'll explain this, what this does. 5.5 and 8. Okay, so what we are gonna do is we're gonna put all the qualities between 0 and 5 and 5. I did not put 5 because if you put 5, it will not include 5. So in this case, I put 5.5 just in the middle. So everything in between 0 and 5 and 5 and 5, 5.5 is gonna be in a separate bin. Anything between 5.5 all the way till 8, so 8 counts there, so all the way till 8 is gonna be in our second bin. So we are splitting our data sets into two bins. We're gonna labels them. Let's create a list. We're gonna label them bad, or maybe instead of calling bad, let's call it average wines and good wines. Okay, so we have created two bins. So you can separate your data sets into two categories. So it's a Panda functions called cut, and we're gonna be working on our data sets y, and the bins are gonna be, so you have to provide, so bins are gonna be the bins. This is how we're gonna split between, first bin is gonna be 0 to 5.5, and second bin is gonna be 5.5 to 8, and our label is gonna be average. So the first bean we're gonna call it average, and the second beans is gonna be called as good. So you can print y now. Let's print it out the first 5 rows. I'm gonna do something. I'm gonna print before and after so that you can see what we did. Okay, so you see here, so this was before, so it has all the wine quality marks, scores, and then we split it into two bins. Anything between 0 and 5.5, we're gonna call them average wine. Anything above 5.5 to all the way till 8, we're gonna call them good wine. So you can see all the 5s were labeled as average, and all the 6 were labeled as good. So we are good to go. Okay, now we're gonna convert this text into a label. Okay, so I'm gonna use scikit-learn from sklearn .preprocessing, import label encoder. I'm gonna import something else as well. I will use standard scalar as well, just to bring them in. Okay, so let's create an object instance of this functions label encoder, and I'm gonna le.fit transform y. So I will convert this into a numerical value. Okay, so you can print y to see what we did here. Okay, so we got y 5. Okay, so now you can see Oh, I did something wrong. So I gotta create y equals to le.fit transform. Okay, so now you see it convert average into 0, and it convert good into 1. So it goes alphabetical A and G. Okay, so you can let's see if we can do value counts here. Oh, we cannot do because it's an array right now. Okay, never mind. We could have done value counts before, but that's okay. So we have only two types of value. I think we almost equally splitted the data. Like if we go here, so we got 600, 581, 53, 10, and then good wines are 18, 199, 630. So it's roughly equally distributed. Okay, so we have splitted our Y, and then let's do our X. So if you notice here, X has all sorts of values, 7.4, 0.7, and everything. So let's standardize this. So SC equals to standard scalar. That's why I imported standard scalar. So let's do SC dot fit transform. And I'm gonna fit transform the entire data sets X. And I'm gonna call it X equals to SC dot fit transforms. All right. Okay, so at this point, our X would be an array, numpy array. So you can check the shape of it. It's 1599 and 11 because we had 1599 entries, right? So in the beginning, we had 1599 entries, and we have 11 columns in our X data set, so that transferred into an array. Okay, so we are good with X. At this point, what we're going to do is we're going to split our data sets into training and testing data sets. So let's do that from scikit-learn. And we're going to do model selections, import train test split. And let's split our data set. Xtrain, xtest, ytrain, ytest equals to train test split. And we're going to be using X, we're going to be using Y, and then we will be using our testing size. So I'm going to be using 0.25, 25% of our data will be on the test size. And shuffle, I want to make sure we are shuffling our data. And random state, let's put 69 there. Okay, so our data sets is split into two. So before I train a neural network, I want to show you how we can do this in some of the basic scikit-learn model. So one common one people use, since this is a classification problem, we can use scikit and from unstable random forest classifier, import random forest classifier. You can use a bunch of different type of classifier. You can use SVM, SVC. Let's just test with this one. So this is a very simple way to do this. Let's create an instance for this one. Random forest classifiers, and let's fit our data set. Xtrain, Ytrain, and let's predict our data set. Predictions equals to model dot predict. Predictions, oh, not model, rfc dot predict, and we're going to be predicting on X test. So what this is doing is we are fitting our data sets using a random forest classifier and Xtrain and Ytrain. Then we are printing our predictions. So let's print predictions. Let's print the first 5, and we will also print the Y test because we're going to compare with it. Okay, so I guess it's doing pretty decent job. Let's see the matrix for this one. So I'm gonna do a couple of them, accuracy score and confusion matrix. Import accuracy score, and we're gonna be importing confusion matrix. let's print it out, both of the scores. So print accuracy score. You're gonna put the actual value, which is y-test, and then you're gonna put the predictions. And then also let's print the confusion matrix. Okay, y-test and prediction. Okay, so you see it's doing pretty decent, 80% accuracy, which is pretty nice. So this one is what it is predicted, and on the top this side is actual. Okay, so it's doing decent. So a simple machine learning model from scikit-learn is doing good. So let's see if we can train this model using a deep learning model. So one thing we have to do when you train a neural network, it needs the output data sets into multi-dimensional arrays. So right now it's a one-dimensional arrays. That's good for simple classifications problem using scikit-learn. But neural network Keras will need to convert this into a binary matrix. Okay, so I will do this with the y-train. So let's print y-train, first 5 data sets, and then I am gonna convert y-train data sets into a binary matrix, one hot encoding, utils 2 categorical, and I'm gonna be using y-train data sets, and num classes would be 2 because we have only 2 qualities, right? It's average and good wines. Okay, so and now I'm gonna print again after. Okay, the reason I did this in a separate way so that we have 2 models to figure out which one is good. So you see the one get converted into a 2-dimensional array. So the one becomes 0 and 1. The second one becomes 0 and 1, but 0 becomes 1 and 0. So the first column stands for 0. The second column stands for 1. So every time you have a 1, the second column has a value. Every time you have a 0, the first column has a value 1. So this just converted into a binary matrix. Okay, so now our y-train is ready to go. So let's build a model. So before we do that, let's from Keras, since we are using Keras from TensorFlow, let's build a sequential model. So from Keras.models, import sequential, and from Keras.layers, we're gonna be using a couple of, this is a very basic model, so we're gonna be using dense, and then we will be using a dropout so that we don't overfit. Okay, so have both of this. So let's call model equals to sequential, and let's add a couple of layers. So first layer would be your input layer, so model.add, and dense, let's put units equals to, again, you can do anything you want. I'm just putting 64. Units equals to 64. Activation functions, let's give it ReLU activation functions, and then let's provide a input shape. So the shape would be, it will be training on how many variables we have. So if you notice, when we did x.shape, it has 11 categories, right? 11 types of qualities. If you go back here, original data, it has fixed acidity, all those properties. We are training on all those properties. So this number has to be 11. Input shape is equals to 11. Or you don't, so input shape is gonna be 11. Again, you don't have to put 11. It's a better way to would be provide what it is, xtrain dot shape, and it's the second index of that shape. So if I print this one give me 11. Okay, so that's looking good. Oh, I'm missing one arrow, sorry, one bracket. Okay, so bracket is closed. Let's add one hidden layer, Again, this one would be a dense. It will be automatically connected. So units, let's put 128. And activation functions is going to be relu. Let's add a dropout layer, model dot add dropout, and I'm going to drop 25% of my data. And let's add another dense layer, units equals to, this time I'm going to be adding one less, 64. Again, activations function, I'm keeping consistent relu. And final layer is going to be our output layer. Again, the output layer is going to be dense, and number of outputs we got is going to be units. So we have two outputs. It could be average or bad, right? No, sorry, average and good. And activation functions, we will be using softmax. All right, so our model is done. Now let's compile them. I'm using Atom Optimizer with default learning rate. Loss functions is going to be binary cross entropy or categorical cross entropy. So I could have used binary in there because our output has only two outputs. So when you have only two outputs, you can do binary outputs, binary cross entropy. And the last one is metrics is gonna be our accuracy. So we will measure our model in accuracy. All right, so everything looks good. So let's summarize model.summary. Okay, so you see we have 17,474 parameters. I don't think it will take long to train. It's not a whole lot of parameters. So we have trained bigger model before, so this can handle your CPU would be okay. So if you are using CPU for this one, you don't need a big GPU on this thing. All right, so let's go over. Okay, so we are ready to fit our model. Let's train our model. Model.fit. We're gonna be xtrain. We're gonna be using training and xtrain and ytrain. And then we need batch size. Batch size you can pass whatever you want, 1,000 at a time. We have only 1,500 data sets, so not a big deal. And then we have epochs. Epochs, how many epochs we want? Let's do 100. It might be overfitting 100, but it doesn't take that long. It'll probably take a few seconds. Verbose equals to 2. I'm not incorporating a validation split because our data set is already too small. I don't want to waste some of the data here. Okay, so I think we look good. So let's see. It's gonna be super quick. So it's already done. You see, it's already done. So we arrive at around 83, 81, 81. So by epoch 76, we are already at 81, 77. Okay, so I think we by third epoch we already at the 72. Then from third to 50 we are on the 80, close to 80. So this is definitely overfitting this model. See, the change is not gradual. Okay, let's do a predictions. So predictions equals to model.predict. Let's do x test, print predictions, print prediction. Let's print first 5. Okay, so it printed out first 5. So you see it's giving a 2-dimensional arrays. So we have to convert into original values. So we can do that by something called argmax functions from numpy. So whichever is the maximum locations. So we're gonna be working on our prediction data, and axis is equals to on our last axis. Okay, so axis is equal to -1. So on the last axis, it wants to give the which one is maximum. So for example, between these two, the maximum is this number here. So that's the index 1. This is index 0, this is going to be index 1. So the output for this one would be 1. So you can check yourself. Predictions 5. The first, let's print it out. Okay, so see, our first number becomes 1 because index 1 is the highest number. So in the second one, index 0 is the highest number. So this becomes index 0. Okay. So now let's print it out our y test so that you can see y test 5, first 5. It doing decent. 10110 10100. Okay, it's doing decent. I think we might get somewhere close to 70-80%. That's what my guess is. Okay, so let's print our accuracy score. See what is our new accuracy score, and this time the actual value is y test and predictions. Okay, we got 76. It wasn't better than what we did with the scikit-learn. Scikit-learn gave us 80% accuracy. If we optimize some of the parameters, that might change. Anyways, so we got 76, 70, 80%. So that's reasonable. It's better than just guessing randomly, right? Okay, so let's do something called, let's plot this confusion matrix equals to confusion matrix y test predictions print confusion matrix. All right, so our confusion matrix is ready to roll. So let's do plot this, a heat map. Let's plot a heat map, and we're gonna be using our confusion matrix and annotations. Yes, we want to annotate. Format equals to D, and CMap is gonna be CMap is what color we want. We want reds. So remember, 0 was average. So let's put label. Create a list. 0 was average, and 1 was good. Come on. So 1 was good. Okay, so let's add xtick label. Xtick labels equals to label. Oh no, I misspelled here. LABAL. So label equals to, and then ytick label is also gonna be equals to label. Okay, let's plot this out. Okay, it looks decent. Let's add few more things. So ax dot set title. So let's call this confusion matrix. Okay, so this is gonna be a string. So confusion matrix for wine quality. Data set. All right, and let's give a set x label. Let's call the x label. So x label is predictions, and x dot set y label. That's gonna be our actual. Okay. Oh no, I think I probably misspelled something. Oh, here, title. All right. Okay, so you see, we predicted, oh, let's increase the font size a bit here. Font size equals to 15, maybe 16. And increase the font size here so that it looks nice. slightly prettier. Okay. Okay, so we predicted 47s to be average, but it turns out to be good. But we predicted 140 of them were pretty good. 140 of them we predicted average, and they were actually average. And 166 of them we predicted to be good, and they're actually good wines. Yes, our model did pretty decent over there. So yeah, that's how we did it. Okay, so I'm gonna stop this video here. So stay tuned for more videos like this.